Good evening, children.
Good evening.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Good evening. Yeah, so we'll just finish off with lines and angles. Last class, I think we completed the extra proofs we had to from polynomials. From polynomials, that's over. Now this is lines and angles, the concluding part of lines and angles. So I'm not starting congruent triangles today. We'll do it in the next class because a few students are not taking up the class today. About 3 to 4 students are not taking up the class today because they have exams at school. So Saturday, in any case, Saturday, we'll start off with congruent triangles. So this is the concluding part of lines and angles. Yes, children, again, you'll have to help me. See, I'll just show you this presentation from the beginning. So you can tell me, we finished this, right? This is over. I'm sure this is over. This is over. Yeah, this is over. This is over. Yeah, this is also over. Yeah, this one I'm not sure, children. Please tell me, have we finished this one?
Yes,
I
ma'am.
think, yeah. Yeah. What about this?
It's over, ma'am.
You're sure, Madhumita?
Yes, ma'am.
Okay, okay, children, fine. This is the proof for angle sum property in a triangle. We finished this, is it? So I'm just double checking.
Yes, ma'am.
Yes, ma'am.
Oh, okay, this one, children, this one.
Completed, ma'am.
Okay, but anyways, we'll do this again. It's an important proof. We'll do this again. What about this?
We completed this, ma'am.
Okay, this one.
Yes, ma'am. You have already sent the pics of these things to complete, ma'am.
This.
Yes, ma'am.
For these pictures I had sent, is it for you to complete?
Yes, ma'am.
Okay, but I haven't explained all this, right? I think from here I have not explained. This one also, I don't think I have explained this. No, I have not explained this. I think we finished till here.
Yes, ma'am.
Yeah, correct. We need to continue from here. We need to continue from here. All right. Have you all written this in your classwork? All of you?
Yes,
Yes,
ma'am.
ma'am.
No, ma'am.
Okay, yeah. So the others who have written it,
Yes, ma'am.
yeah, please go through the proof. Those who have not written, please write down the proof first. Those who have not written, please write down the proof first. I'm waiting for those who have not written the proof to complete it now in the class workbook. Once you're done, I'll start explaining. Those who've already completed this using the pictures which I shared on WhatsApp, you might not have the question, I think. Because in the pictures I sent, I think the proof was given straight away. You may just, write down the question. See, like if you've written the proof, you can just say you've started from here. You can just mark something like this. You can just put an into mark or something like this and write refer question behind, refer question at the back, whatever. Okay, question at the back. And then you can write that question where you have placed now. Because in the images I shared the other day, this question, this one is not there. This figure and directly the proof. This question was not there. So please check that and make a note of the question, all of you, meaning those who have already completed it. Done, children?
Yes, ma'am.
All of you?
Yes, ma'am.
Okay, so this figure is given to us. This figure is given to us. And what is given? In the given figure, M and N are two plane mirrors. So this is M. This is the plane mirror M. This is the other plane mirror N. Okay, M and N are two plane mirrors perpendicular to each other. They are placed perpendicular to each other. That is, this angle is 90 degrees. This is one mirror. This is the other mirror. They are placed perpendicular to each other. So this one is 90 degrees. Show that the incident ray CA. Okay, show that the incident ray CA, this one, is parallel to the reflected ray BD. Is parallel to the reflected ray BD. So this is the ray that's entering. It goes in this direction and comes out of the mirrors like this. So you must prove that this incident ray is parallel to this reflected ray. So there's a ray hits the mirror M at A and it's reflected along AB. So the incident ray CA, this ray CA hits the mirror M at A and is reflected along the path AB, where it hits the second mirror N at B and is reflected along the path BD. We need to prove that this incident ray CA is parallel to the reflected ray BD. That is, this ray hits the mirror, it's reflected along this path. And now this reflected ray becomes the incident ray for the second mirror N. And that is again reflected out in this direction. So this is the incident ray and this is the finally reflected ray. You need to prove that these two rays, this one and this one, they are parallel to each other. The mirrors are placed perpendicular to each other. The plane mirrors M and N. The plane mirrors M and N are placed perpendicular to each other. So this is 90 degrees. So the array hits mirror M at A. It's reflected along AB. It hits the second mirror N at B and is reflected along the path BD, we need to prove that CA is parallel to BD. All right. So given, you know what to write, plane mirrors M and N are placed perpendicular to each other. And we need to prove that AC is parallel to BD. AC is parallel to BD. This is what we'll have to prove. Construction. So whenever it is about plane mirrors and rays hitting at a point on the mirrors, you'll have to draw the normals. Okay, so from where do you draw the normal? So this is the point. This is the point where the ray hits the first mirror M. All right, so it hits like this and it's reflected like this. So here is the normal. See, this is the incident ray. This is the reflected ray. So this is the normal. The normal lies between the incident and the reflected ray. The normal is perpendicular to the mirror. That is the important thing. The normal is perpendicular to the mirror and it lies between the incident ray and the reflected ray. The normal is perpendicular to the mirror. At which point is it perpendicular? At the point the ray strikes the mirror. At the point where the ray strikes the mirror. At which point does the ray strike the mirror? At A. So the normal is drawn through A. It's drawn through A. It lies between the incident ray and the reflected ray, the normal. And it is perpendicular to the mirror. And it is perpendicular to the mirror. So this is about the normal. So this is the normal. Okay, this is the normal drawn through A. Okay, this is the normal drawn through A and it's perpendicular to the first mirror. It's perpendicular to the first mirror, M. And this is the, so now this reflected ray becomes the incident ray for the second mirror at B. So B is the point where the ray strikes the second mirror N. So from this point B, we draw the normal. Now, what are the properties of the normal? The normal lies between the incident ray and the reflected ray. The normal is perpendicular to the mirror at the point where the ray strikes the mirror. So this is the normal and the point B. This is the point where the ray strikes and is reflected. So the normal is perpendicular to the mirror at that point. All right, so this is the construction. So this is the construction, drawing the normals and let the normals meet at P. Let the normals, let them meet at P. Let the normals meet at P. Now, by the property, this normal, this is 90 degrees here. Here also normal, so it's 90 degree. And here this is 90 degrees because the mirrors are placed perpendicular to each other. Now this one is a quadrilateral. OBPA is a quadrilateral. OBPA is a quadrilateral. In the quadrilateral, you see that this corner is 90 because the mirrors are perpendicular to each other. This one is 90 because the normal is perpendicular to the mirror. This one is 90 because again the normal is perpendicular to the mirror. And by the angle sum property of a quadrilateral, this angle also has to be 90 degrees because here the total is 270. 90, 90, 90 is 270. 360 minus 270 because the sum of the four angles in a quadrilateral is 360 degrees. Minus 270 is 90 degrees. So the fourth angle is also 90 degrees. That means this one is 90. Because this is 90, this is 90 and this is 90. This is because normal. This one is because the mirrors are placed perpendicular to each other. So this is 90. This is one mirror. This is the other mirror. They are placed perpendicular to each other. So in the quadrilateral, OBPA, three angles are 90 degrees. 1, 2, 3. These three angles are 90 degrees. So by the angle sum property, the fourth angle is also 90 degrees. That is the first part. Okay, that's what you see here. Till here, that's what you see. Okay. Next, now take up this triangle. Now take up this triangle APB. Okay, whatever you call it, this one, this triangle. Take up this triangle. Take up this triangle. Now in this triangle, we know that this angle is 90 degrees. We just found that this angle is 90 degrees. So this one is a right triangle. This one is a right triangle. We always, okay, in a right triangle, we know that the sum of the two acute angles is 90 degrees because this is 90, this is 90. So 180 minus 90. The sum of the remaining two angles, that is this angle plus this angle, will be 90 degrees. The sum of the remaining two acute angles is 90. Simple, no? Because this angle is 90 degrees. So the sum of the remaining two angles will be 90. So angle 2 plus angle 3 is equal to 90 degrees. 180 minus 90 is 90. So angle 2 plus angle in triangle APB, in this triangle APB, since this angle is 90, the remaining sum is 180 minus 90, 90. The remaining sum is 90. So angle 2 plus angle 3, angle 2 plus angle 3 is equal to 90 degrees. Okay, angle 2 plus 3 is equal to 90 degrees. That's how we have in triangle. See, I've written in right triangle BPA. In right triangle BPA. See here, in right triangle BPA, 2 plus 3 is 90. You'll wonder how 2 plus 3 is 90 because what I just said, the sum of the two acute angles in a right triangle, the sum of the two acute angles will be 90 degrees. So 2 plus 3 is 90. Now let's double it. Okay, multiply both the sides by 2. Multiply both the sides by 2. So twice of 2 plus 3 is equal to twice of 90. So twice of 2 plus 3 meaning twice of 2 plus twice of 3 is equal to 180. Now twice of 2 meaning 2 plus 2. Twice of 3 meaning 3 plus 3 is equal to 180. Now we know that angle 1 is equal to angle 2 because the angle of incidence is equal to the angle of reflection. And angle 3 is equal to angle 4, again because the angle of incidence is equal to the angle of reflection. Now we have discussed this in the, in one of the earlier classes when we understood this proof. When we understood this proof, I have mentioned about angle of incidence and angle of reflection here. Okay, but anyways, we'll see it again. We'll see it again. So now say this is the mirror. This is the mirror. This is the incident ray, and this is the reflected ray. This is the reflected ray. This is the normal. This is the normal. Okay. And if see, can you see the arrow? Can you see the arrow? The ray, this is the incident ray. So you can see the arrow like this. It hits the mirror here and is reflected along this path. You can see it. It's going out of the mirror in this direction. Okay. And this is the normal. This is the normal, making 90 degrees with the mirror. Now this angle is called the angle of incidence, and this angle is called the angle of reflection. The angle of incidence is the angle between the normal and the incident ray. The angle of incidence, the angle of incidence is the angle between the normal and the incident ray. The angle between the normal and the incident ray is the angle of incidence. The angle between the normal and the reflected ray is the angle of reflection. This is the normal. This is the normal. The angle between the normal and the incident ray, or between the incident ray and the normal. The angle between the incident ray and the normal is the angle of incidence. And the angle between the reflected ray and the normal is called the angle of reflection. And by the laws of reflection, angle of incidence is equal to the angle of reflection. By the laws of reflection. By the laws of reflection is when a ray hits a smooth surface, not any irregular surface. When it hits an irregular surface, it's completely different. When a ray hits a smooth surface like a mirror, and then the angle of incidence is equal to the angle of reflection. So this is the mirror, incident ray, reflected ray, normal. This is the angle of incidence. This is the angle of reflection. Normal. Angle of incidence, angle of reflection. Normal is 90, makes 90 degrees with the mirror. All right, I hope all of you understood this. So now we were here. Angle 2 plus angle 2 is equal to angle 3 plus angle 3. But angle 1 is equal to angle 2 because the angle of incidence is equal to the angle of reflection. So instead of 2, you can write 1 because 1 and 2 are equal. See, angle of incidence is equal to angle of reflection. That means angle 1 is equal to 2. 1 is equal to 2. And also 3 is equal to 4 because 3 is the incident angle of incidence and 4 is the angle of reflection. So 3 is equal to 4. So here instead of 2, I'll write 1 because 1 and 2 are equal. And here instead of 3, we'll write 4 because 3 and 4 are equal. 3 and 4 are equal. So instead of 3, we'll write 4. So now we have a new result. Now we have a new result. Angle 1 plus 2 is equal to 3 plus 4 is equal to 180. Now what is angle 1 plus 2? Angle 1 plus 2 is this full angle. Angle CAB or BAC. CAB or BAC. And what is 3 plus 4? What is angle 3 plus 4? 3 plus 4 is this one. This one, DBA. DBA, this angle, DBA is equal to 180. Now see the figure like this. Now see the figure like this. Okay. Now this is D, this is B, this is A, this is C. All right. Now we have proved that this angle plus this angle is 180. You can see here BAC. BAC is this angle. BAC is this angle. And DBA, this one. We have proved that the sum of these two angles is 180. But they are co-interior angles made by the transversal AB with the lines CA and DB. And they are supplementary. The co-interior angles are supplementary. See, these two angles are co-interior angles made by the transversal AB with the lines BD and AC. And the co-interior angles are supplementary. This means that AC is parallel to BD. So AC is parallel to. It's a very simple proof. I'll just do it again in short, So construction normal. Okay. And then you'll have to take up this quadrilateral. 90 degrees because normal, 90 because normal. This is 90 because the mirrors are placed perpendicular to each other. So by angle sum property, this is also 90 degrees. So that is step 1. Step 2 is to take up this triangle. Step 2 is to take up this triangle, wherein we know that this angle is 90 degrees. So in a right triangle, the sum of the two acute angles is equal to 90 degrees. So angle 2 plus angle 3 is equal to 90. So you'll have to begin with that. And then double, multiply both the sides by 2. And then here, instead of 2, you say 1. Instead of 3, you say 4. Because angle of incidence is equal to angle of reflection. So then you get a new result. 1 plus 2 is this angle. And 3 plus 4 is this angle. So you get a result like this. This angle plus this angle is equal to 180 degrees. But they are co-interior angles. So this line is parallel to this line. That's what we have to prove. AC parallel to BD. Therefore, AC is parallel to BD. Isn't it a very simple proof, children?
Yes, ma'am.
Yes.
Yeah. Just give me 1 minute time to look at the proof. If you have any questions, you can ask me. Yes, children. Shall we go to the next one? You have any questions?
No doubts, ma'am.
All right. Yeah, this is the next one. Those who have already written this proof, you may go through. But again, the question, you will not have the question. So please make a note of the question. Yeah, the others kindly write down the proof. I'll explain. May I know how many of you are writing? Krishmika, are you writing now? Okay, Netra is writing
No,
now.
ma'am.
Okay. You said yes, Krishmika?
No, ma'am.
Oh, you've already finished writing, is it?
Yes, ma'am.
Okay, Danya?
Completed writing, ma'am.
Adumita?
Completed writing, ma'am.
Okay. Netra's writing now, right? Okay. And Srijana?
Completed, ma'am.
Raja?
I'm writing.
Okay, and Tanishka?
Writing, ma'am.
Yeah, okay, fine. Write down, Chitta. I'll just have some water and get back. Please write. Done, children?
Yes, ma'am.
Yes,
Yeah.
ma'am.
All right, children. So here, so this is, related to, see here, this is about, this question or this figure is about two plane mirrors placed perpendicular to each other. And this one, which you have in NCERT, this one is not from NCERT. This one is not from NCERT. Okay, but you have this in NCERT, wherein two plane mirrors are placed parallel to each other. The two plane mirrors here are placed parallel to each other. What we just understood is the proof about, or is a proof where the, where in the question the mirrors, the plane mirrors are placed perpendicular to each other. Okay, and then here you saw, yeah, in this question, this is from NCERT. This is from NCERT. So what is the situation here? What is the situation here? You have a triangle. You have a triangle. This is from NCERT. You have any triangle. Okay, any triangle. Two sides are produced. Two sides of this triangle are produced. Exterior angles are formed. When the sides are produced, exterior angles are formed. The exterior angles are bisected. The exterior angles are bisected. The bisectors meet here. Okay, the bisectors meet here. You need to prove that this angle is equal to 90 minus half of this angle. You need to prove that this angle is equal to 90 minus half of this angle. See, you can remember this result because it's very useful in answering 1 mark questions. You can simply, they'll give you this angle and ask you to find this, or they'll give you this angle and ask you to find this. So simply write the result. Angle BOC is equal to, see, it need not be BOC in the figure given to you. It can be some, so the names of the points can be different, or the vertices can be different. So with respect to this figure, so BOC is equal to 90 minus half of BAC. See, I'm telling you the positions. This one, this angle is equal to 90 minus half of this angle. 90 minus half of this angle. So supposing this angle is given, write that angle here is equal to 90 minus half of, you'll have to say find BAC. So work this, you know how to solve an equation. So solve this equation and find the value of BAC. That's all it is. So this one is from NCERT. I repeat, where you have a triangle, two sides of the triangle, they are produced. Exterior angles are formed. Each of the exterior angles is bisected. The bisectors meet at a point. Now you will have to prove that the angle between the bisectors of the exterior angles, the angle between the bisectors of the exterior angles is equal to, that is this angle is equal to 90 minus half of this angle. This angle is equal to 90 minus half of this angle. Now, for example, say this angle is given to be say like 30 degrees. Okay, so what is the condition, or what's the equation? BOC is equal to 90 minus half of angle BAC. So what should you do now? BAC is given. So BOC is equal to 90 minus half of BAC. How much is BAC? 30 degrees. Substitute in the appropriate place, because BAC is given, you should put 30 here. So 2 1s are 2 15s are. So 90 minus 15. 90 minus 15 is 75 degrees. So this angle is 75 degrees. This angle is 75 degrees. Is it clear, all of you?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, so remember this result, children. Remember the position, How do you remember this result? Just remember the positions. This angle, supposing you call it A and say this is B. Okay, A is equal to 90 minus half B. That's all. Remember the position, this position, this position. Okay, so the angle here, A, is equal to 90 minus half of B. This is what it is. So if supposing A is given, substitute here and find B, solve and find B. If B is given, substitute here and solve and find A. Okay. So this is what we have in NCERT. Now you can see here that in triangle ABC, the base angles are bisected. The base angles, these are the two base angles. The base angles are bisected and the bisectors meet here. The bisectors meet here. You need to prove that this angle is equal to 90 plus half of this angle. This angle is equal to, this angle between the bisectors is equal to 90 plus half of this angle. There it was 90 minus half of the vertical angle. Here it is 90 plus half of the vertical angle. Vertical angle is this one, vertical angle of the triangle, this one. Here we have a triangle. We have a triangle. The base angles are bisected. They are bisected. The bisectors meet here. Now the angle between the bisectors, so supposing I call it X and I call the vertical angle Y. Okay, the angle between the bisectors is X. So we'll have to prove that X is equal to 90 plus half of Y. The angle between the bisectors is equal to 90 plus half of the vertical angle. Vertical angle of the triangle is Y. So X is equal to 90 plus half of Y is what we have to prove here. All right, children?
Yes, ma'am.
Okay.
Yes, ma'am.
All right. So again, the proof is very simple. Listen to me carefully. First, take up this triangle. And use angle sum property. Take up this triangle. So in this triangle, this angle plus this angle is equal to 180. So how will we refer to this angle? See, first you write, you know how to name this angle, no? Whatever angle OBC plus angle OCB, what you see here. Okay, this one is angle OBC, this one is OCB, and this one is BOC is equal to 180. In this triangle, the small triangle OBC, the sum of the three angles is equal to 180 degrees. Write down that first. Now in the next step, what is this angle actually? It is half of the full angle B because it's bisected, no? This is the bisector. This one is the bisector. This is the angular bisector. That means if this full angle is say 50 degrees, it'll be 25 here and 25 here. OB or BO is the bisector of angle B. Okay, so since this is the bisector, these two portions are equal. So now you have written angle OBC. OBC, this one. OBC is equal to half of this full angle. What is the other way of writing angle OBC? What is the other way of writing this angle OBC? This angle is equal to half of this full angle B. Because see, you know that, see here, this full angle is how much? 50. This full angle is 50. This is 25. This is 25. So how do you express this 25? 25, this 25 is equal to half of this full angle 50. This full angle 50. Like that. So instead of OBC, say half of angle B. And instead of this angle OCB, instead of this angle, say half of C. Half of C. OCB is nothing but half of C. Write this one as it is. BOC as it is. That's the next step. Okay, so start with the angle sum property of this triangle. That's the first step. In the next step, this one is half of B. This one is half of C. Write this as it is equal to 180. Now take out half common between the first and the second. Between the first two, half is common. Bring it out. Half of B plus C plus BOC is equal to 180. Okay. Now what is B plus C? What is angle B plus C? What is angle B plus angle C? We know that angle A plus angle B plus angle C is equal to 180. So angle B plus angle C is equal to 180 minus A. 180 minus angle A. I'll write it again. We know that in the whole triangle or in the big triangle ABC, angle A plus angle B plus angle C is equal to 180. So from this, we know that angle B plus angle C is equal to 180 minus angle A. 180 minus angle A. That is what I've written here. B plus C is equal to 180 minus angle A. B plus C is equal to 180 minus angle A. You can make a note of it. Supposing you did not realize that, you can write angle A plus angle B plus angle C is equal to 180. Therefore, from this we have angle B plus angle C is equal to 180 minus angle A. When you transpose A, when it goes to the other side, you have B plus C is equal to 180 minus angle A. So instead of B plus C, in the next step, we have written 180 minus angle A. Plus BOC is equal to 180. Now, if you have half of A minus B, it's nothing but A by 2 minus B by 2. Because when you multiply, half into A is A by 2. Half into B is B by 2. Half into A. See, how do you multiply? Half into A. A into 1 is A by 2. Half into B. B into 1 is B by 2. B by 2. Okay. So when you multiply, you get half into 180 is 180 by 2, and half into angle A is angle A by 2 plus BOC is equal to 180. Now we know that 180 by 2 is 90. Angle A by 2 as it is, plus BOC is equal to 180. Now we got the result. We'll have to get BOC is equal to something. So have BOC alone on one side. Have this alone on one side, because see the result here. BOC is equal to something. So have BOC alone have BOC alone on the left-hand side and transpose the remaining. So BOC is equal to this 180 minus 90 plus A by 2. Transpose these two. Take these two to the other side. So it will be plus A by 2 minus 90. See, this 180 which is already there. So 180 minus 90 is 90. 180 minus 90 is 90 plus A by 2. Plus A by 2. A by 2 is nothing but half of A. A by 2 is nothing but half of A. So we proved that angle BOC is equal to 90 plus half of A. Yes, children, I'll give you some time to go through the proof and you can ask me if you have any further questions.
Ma'am?
Yeah.
Ma'am, in the fifth step, it says half of 180 minus angle A plus angle BOC is 180 degrees, no ma'am?
Which step, ma?
Fifth one, ma'am.
Fifth, okay, 1, 2, 3, 4, 5. This one?
No ma'am, actually the fourth one.
Okay, fourth one. Yeah, tell me.
How does angle B plus angle C become 180 minus angle A, ma'am?
Okay, fine. So now look at this triangle ABC. All right, ABC. Now tell me, what is angle A plus angle B plus angle C? What is
180
it?
degrees, ma'am.
180 degrees. Okay. Now what is angle B plus angle C?
180 minus A, ma'am.
180 minus angle A. That's what I've substituted. B plus C is equal to 180 minus angle A.
Yes, ma'am.
Okay, maybe I can, I should make it more clear like this. When I say half of angle B, I'm talking about half of ABC. Half of ABC it is. Okay, here angle B is angle ABC. Angle B means, is that clear, children? Because when we say angle B, it is the whole angle B. When we simply say angle B, it is the whole of angle B. When we say angle C, it's the whole of angle C. Any doubt here, Madhumita? Half of angle B and half of angle C?
No, ma'am, no doubts there.
Okay,
I
fine.
understood my doubt now, ma'am. It's clear.
Okay. Because in the whole triangle, angle A plus angle B plus angle C is 180. So this B plus C, angle B plus angle C is equal to 180. When you transpose, you'll get minus angle A. So B plus C is equal to 180 minus A. That's what I've written. B plus C is 180 minus A.
Yes, ma'am.
All right. Very good. Yes, children? All right, Shiva. I assume no questions. We'll go to the next one. Yeah, please write down. Again, as I've been telling you, students who have already written might not have this question. So please make a note of this question. Yeah, others who have to write, please write down. Done writing, children?
Yes, ma'am.
No, you've already finished. Those
Only
who,
the question, ma'am.
yeah, those who are writing now. Raja, Netra, and
Yes, ma'am.
Tanishka.
Completed.
Sure, Tanishka?
I'm completed.
Okay. Netra and Raja?
Yes, ma'am. Completed.
Yes, ma'am.
Okay. All right. So this again is a very simple proof, but see how it goes. Now, so you're given a triangle ABC here. In a triangle ABC, angle B is greater than angle C. This angle B. Don't worry about that. Don't worry much about this information. Angle B is greater than angle C. Okay. If AD is perpendicular to BC, AD, see here AD is perpendicular to BC. You can see it's marked. AD is perpendicular to BC, 90 degrees. We all understand that this is the AD, this is the AD, this is BC. AD and BC, they are perpendicular to each other. So 90 degrees here. if AD is perpendicular, if AD is perpendicular to BC and AE is the bisector of angle BAC, AE is the bisector of angle BAC. See, this is BAC, and this one is the bisector of this angle. That means this portion is equal to this portion. If it's bisected, if an angle is bisected, it's divided into two equal angles. Same thing with the line segment. If you bisect a line segment, you're dividing the line segment into two equal halves. Bisecting means dividing into two equal halves. So see here, this angle, this line segment AE bisects this angle BAC, this angle. So this is angle BAC, children. This is angle BAC. Can you see AE is here? So that means this portion is equal to this portion, which means angle BAE is equal to angle CAE. All of you should tell me if you understand that. See, AE is the bisector. This is the bisector, AE. This one is the bisector. Of which angle? This full angle BAC. That means BAE is equal to CAE. See, you can take that separately. See, this is BAC like this. There's B here. There is A here and there is C here. This is angle BAC. And this is AE. See, this is AE. This is AE like this. AE bisects angle BAC. That means this angle is equal to this angle. So see here, this angle BAE is equal to this angle. All of you understand that? AE is the bisector of angle BAC. All of you please see, watch out for that angle BAC, and see that line segment AE. AE divides angle BAC. That means AE bisects angle BAC. That means divides it into two equal angles. Please understand that. Is that fine?
Yes, ma'am, I understood.
Yes,
All right.
ma'am.
Yes, ma'am.
All right, very good. Then prove that DAE, where is DAE? This one, this DAE. Prove that DAE is equal to half of angle B minus half of angle B minus angle C. See, when they say angle B, this full angle. C meaning this full thing. You should prove that DAE, this angle DAE is equal to half of B plus C. Okay. So to prove this result, so what is given, basically what is given here, you can see a 90 degrees here, that's one thing. And then this angle is equal to this angle. This is given. These are the two things given to you in the question. These are the two things given to you in the question. See here, this perpendicular means this is 90 degrees and AE is the bisector of BAC. That means this angle is equal to this angle. These are the two things given to you in the question. With the help of this information, you will have to prove that DAE is equal to half of angle B minus angle C. So that this is DAE. So let's begin with angle DAE. Okay, see, I've written whatever is given. We are given a triangle ABC. AE bisects angle BAC, and also AD is perpendicular to BC. This is given to us. Okay, we have to prove that DAE is equal to half of B minus C. Okay, now let's start with DAE. We'll have to prove that DAE is equal to something, right? So we'll start with DAE. We have to prove that DAE is equal to something. You forget this one. We'll start with angle DAE. See here, angle DAE is equal to. So you write something about DAE. What can you write about DAE? See, this is the angle DAE. What can you write about this? This angle DAE is equal to, okay, maybe I've written this directly, children. Now, let me include some steps. In triangle, listen carefully, in triangle ADE, all right, in triangle ADE. Now, what is angle ADE plus angle ED, 1 minute. In triangle ADE, children, what is angle DAE plus angle ADE plus angle AED? What is this equal to? AED equal to, tell me.
180, ma'am.
180 degrees, 180 degrees. Now have DAE as it is. DAE is E plus. What is ADE? How much is ADE?
90 degrees, ma'am.
90 plus angle AED is equal to 180. So now what is DAE? What is DAE? DAE is equal to 180 degrees minus 90 degrees minus AED. So angle DAE is equal to 90 minus AED, 90 minus angle AED. That's what I've written straight away, 90 minus AED. Now, it's not difficult to write it straight away. It's not at all difficult to write it straight away. You can make a note of this. Take a picture. Okay. Now, it's not at all difficult to write this straight away. I'll tell you why. Because in this triangle, this angle is 90 degrees, children. Okay. So 180 minus 90 is 90. So the sum of this angle and this angle is 90 degrees. Okay. The sum of these two angles is 90 degrees. So how much? What will be this angle DAE? This angle DAE? It will be 90 minus this angle. Because the sum of these two angles, the sum of which two angles? The sum of DAE, angle DAE, and that other angle AED, that other angle AED. The sum of these two angles is 90. Why is it 90? Because in the triangle, this angle is 90. So the remaining two angles will be 180 minus 90, which is 90. So the sum of this angle and this angle, that is DAE. See here, I've written DAE plus AED is equal to 90. So from this DA is equal to 90 minus AED. That's what I've written straight away. Now again, I'm going to wait for some time so that all of us understand. All the while I've been telling you how I wrote this one, how I wrote this one. We have not gone ahead at all. That the first line. Children, I'll just come back. There's somebody at the door. I'll just come back. Please understand that. All right, children, let's proceed. So that's how I wrote the first step, 90 minus AED. That's it. Once you write this, just take it from me, you have completed the proof. Because now our job is only to introduce B and C. Introduce B and C. B and C are angles of the whole triangle ABC. B and C are the angles of the whole triangle ABC. There's one whole triangle, no, that outermost triangle ABC. Okay, so B and C are angles of this triangle. Now somehow you should introduce these two angles. That's all. After writing this one, see, why did we write this? Because we have to prove that DAE is equal to something. So what have we done here? Where is DAE? DAE is in the small triangle DAE. So the result we could write is this angle DAE is equal to 90 minus this angle. 90 minus this angle, because the sum of these two angles is 90 degrees. So this angle will be equal to 90 minus this angle. We wrote that. After that, what? Now we are going to write 90 in a different way. But the different way should, somehow include B and C. It can include something else, but there should be B and C. Similarly, that is C. Okay, I'll tell you like that other way of writing should include angles A, B, C. Should include angles or should be in terms of angles A, B, C. Because that's what we have to get here. So now what is the other way of writing 90 degrees? The other way of writing 90 degrees is in the whole triangle ABC. The whole triangle ABC, we know that angle A plus angle B plus angle C is 180. Then what will be half of angle A plus angle B plus angle C? What will this be? 90 degrees, because we know that A plus B plus C is 180. So half of 180 is 90. So the other way of writing 90 degrees is half of A plus B plus C, half of angle A plus angle B plus angle C, because angle A plus angle B plus angle C is 180 degrees and half of 180 is 90. So the other way of writing 90 degrees is half of angle A plus angle B plus angle C. Is this understood, children?
Yes, ma'am.
Yes.
And why did we choose to write like this? See, we are happy to see B and C. We are happy to see angle B and angle C because we need that in the result. Okay, here it is B minus C, but here it's B plus C. That's okay, but we have got somehow we got B plus B and C. Okay. Okay, so that's about this one. Now write this minus as it is. Now AED. How to write AED? Where is AED? AED, this one. How do you write this angle? This angle. I said you cannot write it in any way. You should write it so that you get these angles ABC in terms of ABC. So how do you write this angle? AED. So see here, I'll just show that angle alone. It's like this. Okay, there's A here. There is E here. There is C here. And this is the angle AED. You can see here. This is the angle AED. This is that angle AED. Yes or no, children?
Yes, ma'am.
Okay. Now this is the exterior angle. This exterior angle is equal to the sum of the two interior opposite angles. So this angle plus this angle. This exterior angle is equal to the sum of the two interior opposite angles. So this angle, leave this interior angle, leave this one, is equal to this plus this. I'll draw it again. See here. This is AE, AC, this is D here, this is E here, this is C, and this is A. This is AED. This one is AED. Leave this angle. This one plus this one. So angle AED, the exterior angle is equal to the sum of the two interior opposite angles. So this one is angle C. This one is angle C. What about this one? What about this one? See here, this is what EAC, this angle, this angle. This angle we know is half of angle A because AE is the bisector. AE is the bisector of angle A. AE bisects angle A. So this is 1/2 of angle A. This one is 1/2 of angle A. And this is the other half of angle A. This is 1/2 of angle A. This is the other half of angle A. So since AE is the bisected of the vertical angle A, we know that angle EAC is equal to EAB. And here we have what? Here we have what? This exterior angle is equal to the sum of the two interior opposite angles, these two angles. So this angle is nothing but half of angle A. And this is angle C completely. So that's what you see here. AED is nothing but using the exterior angle property in a triangle. Using the exterior angle property in a triangle, this angle is equal to this angle plus this angle. This angle is nothing but, this one is nothing but half of angle A. And this one is angle C. This one is angle C. So this exterior angle is equal to half of angle A plus C. See here, half of angle A plus C. Is this understood, children?
Yes, ma'am.
Yeah, that's all. We are done. Next what, just open the bracket. So half into angle A, half of angle A, half into angle B, half of angle B, half into angle C, half of angle C, minus half angle A, minus into plus minus half, so not half, minus angle C. Now simplify, plus half of angle A minus half of angle A cancels. And then how do you subtract these two? How do you subtract these two? This is like minus 1, meaning this is the complete angle C. It's like, half x minus x. It's like this. Half x minus x is minus x by 2. This gets cancelled. How do you simplify this and this? See here, it is plus half angle C minus angle C. How do you simplify this? So you can say take angle C common. Angle C is common. So what will you get in the bracket? Half minus 1. Because this is 1 here, this 1 here. So you get half minus 1. What is half minus 1? Minus half. So minus half angle C. Minus half angle C. So when you simplify, you get minus half angle C. This one as it is. This half angle B as it is. So this gets cancelled. This half angle B as it is, and half of angle C minus angle C. Take out angle C common. You don't have to show these steps, children. You can just do it in your mind. Just in case you're confused, this is what it is. Take out half angle, take out angle C common, and the bracket you have half minus 1, because there is 1 here. Half minus 1 is minus half angle C. That's what is here. So we got it. We got it. So DAE is equal to, take out half common, half of angle B minus angle C, because half is common, half of angle B minus angle C. So the start is very important. How to start, that's very important. So since we'll have to prove angle DAE is equal to something, start with angle DAE. Write angle DAE in the simplest way you know. So this angle DAE plus this angle is 90. The sum of these two angles is 90. So this angle will be 90 minus this angle. That's how we started. That's all. Now 90 is written as half of angle A plus angle B plus angle C. And this one using the exterior angle property. That's it. Yes, children, I'll give you some time to go through the proof. You can ask me if you have any questions. Yes, children, any questions?
No doubts, ma'am.
No doubts, ma'am.
No, ma'am.
No doubts, ma'am.
All right, children. Just a minute, children. All right. Yeah. So this is the next one. Prove that the opposite angles of a parallelogram are equal. Prove that the opposite angles of a parallelogram are equal. All right. If we mark the angles 1, 2, 3, and 4, what is it's a parallelogram. So which means both the pairs of opposite sides are parallel. Both pairs of opposite sides are parallel. So you can see it's marked here. AB is parallel to AB is parallel to CD and BC is parallel to AD. It's a parallelogram, so both the pairs of opposite sides are equal, of course, and parallel. Forget equal. We learn the properties of a parallelogram in the chapter quadrilaterals. So you know from the name parallelogram, it means both the pairs of opposite sides are parallel. Okay. So now, what is angle 1 plus 2, children? What is angle 1 plus 2?
180 degrees, ma'am.
Reason?
Ma'am, because
Co-interior
of co-interior angles.
Co-interior angles are supplementary. What is angle 2 plus 3?
180 degrees, ma'am. Co-interior angles again.
Yeah. So now equating these two, angle 1 plus 2 is equal to angle 2 plus angle 3. Okay, because both are equal to 180. Angle 1 plus angle 2 is equal to angle 2 plus angle 3. So 2 on either side gets cancelled. So we have the result angle 1 is equal to angle 3. All right. So we proved that one pair of opposite angles is equal. Same thing. So now in the similar way, we'll have to prove that angle 2 is equal to angle 4. So just write one more result for that. So what is angle 1 plus angle 4? What is angle 1? 180 degrees. Now we equate these two. Equate these two. Angle 1 plus angle 2 is equal to angle 1 plus angle 4. So 1 on either side gets cancelled and you have the result angle 2 is equal to angle 4. So like this, we can prove that both the pairs of opposite angles are equal. So I think prove that the opposite, I think I proved only one pair here. Okay, so let me write the answer here. So again, children, you can write, all of you need to take down this answer. So here I think I've proved only one pair of opposite angles is equal. So all of you need to take down this proof. So mark the angles 1. You don't have to use the numbers also, you can straight away use A, B, C, D. Yeah, children, so the proof goes like this. You can say given parallelogram ABCD, given parallelogram ABCD, to prove that angle A is equal to angle C and angle B is equal to angle D. Proof. Okay. So so now if you want to say that angle A plus angle B is 180, you should say BC is parallel to AD or AD is parallel to BC. And which is a transversal? AB is a transversal. AB is the transversal. AB is a transversal. So you have angle A plus angle B is equal to 180. Now you can write 4 results like this. You can write 4 results, children. See here. Angle A plus angle B is 180. Angle B plus angle C is 180. Angle C plus angle D is 180. Angle D plus angle A is 180. You can write 4 results, right? Any 3, that's enough. Any 3. You can write 4 results here. Angle A plus angle B is 180. Co-interior angles are supplementary. Angle B plus angle C is 180. Co-interior angles are supplementary. Angle C plus angle D is 180. Co-interior angles are supplementary. Angle A plus angle D is 180. Co-interior angles are supplementary. You can write 4 results. Write any 3. Any 3. Okay, and on equating, you can get these results. Okay, so I'm just writing any 3. So this is the first one. So this is 1. Reason is co-interior angles are supplementary. You should mention that. Okay, I'm just writing co-interior, and I'm calling that result 1. Now, to show that B plus C is 180, to show that, or to write B plus C is 180, again, for the same reason, co-interior angles and reason, and this is 2, equation 2. Which are the parallel lines, children? B plus C is 180. So which are the parallel lines?
AB and DC, ma'am.
Yeah, AB is parallel to CD, and which is a transversal?
BC, ma'am.
BC is the transversal. BC is a transversal. Okay. Now, I want to write C plus D is 180. C plus D is equal to 180. Co-interior angles are supplementary. Co-interior angles are supplementary. Result 3. Now here, which are the parallel lines?
AD and BC, ma'am.
Yeah, AD is parallel to BC. AD is parallel to BC. And which is the transversal?
DC, ma'am.
DC is the transversal. Or you can write the same. BC is parallel to AD. And CD is a transversal. CD is the transversal. Exactly what you said, Madhumita, is a transversal. Okay, now from 1 and 2, 1 and 2. From 1 and 2, what do you get? Angle A plus angle B. Angle A plus angle B is equal to angle B plus angle C. So B on either side gets cancelled, and you prove that angle A is equal to angle C. Now, which one to equate to get B is equal to D? Which one will you equate to get B is equal to D?
Angle B plus C and equation 2 and 3, ma'am.
2 and 3, very good. From 2 and 3, from 2 and 3, what is 2? Angle B plus C is 180. And what is 3? C plus D is 180. So C on either side gets cancelled, and B is equal to D. Yes, all of you must take down this. All of you, please take down this.
Completed, ma'am.
Yeah.
Completed, ma'am.
All right, children.
Complete.
Yeah, children.
Completed, ma'am.
Yeah. Yes. Children. So here, we have to prove that this angle is 90 degrees. This one is 90 degrees. So these are two parallel lines. These are two parallel lines cut by a transversal, and these are a pair of co-interior angles. These are a pair of co-interior angles. EG bisects this angle, and FG bisects this angle. See here, two parallel lines transversal. These are a pair of co-interior angles. Bisector, bisector. The co-interior angles are bisected. Now the bisectors meet here. You need to prove that this angle is equal to 90 degrees. You need to prove that the bisectors intersected right angles. So if two parallel lines are cut by a transversal, see, it's very easy to, say the statement. See here, how do you say the statement? If two parallel lines are intersected by a transversal, then prove that the bisectors of what? The bisectors of a pair of co-interior angles, or you can say the bisectors of a pair of interior angles on the same side of the transversal. Interior angles on the same side of the transversal also means co-interior angles. If you say co-interior angles, you don't have to say on the same side of the transversal. When you say co-interior angles, you don't have to say on the same side of the transversal. But when you just say interior angles, there are four interior angles. When you just say interior angles, there are four interior angles. Which interior angles? Interior angles on the same side of the transversal. That's how it's expressed here. When two parallel lines are intersected by a transversal, then prove that the bisectors of a pair of the bisectors of the interior angles on the same side of the transversal. So these are the interior angles on the same side of the transversal. Or you can take this one also. You can also take these two. Okay, so you should prove that the bisectors of the interior angles on the same side of the transversal meet at right angles. The bisectors, they meet at right angles, or the bisectors intersect at right angles. So what are these? These are interior angles on the same side of the transversal. These are interior angles on the same side of the transversal. Bisector, bisector. So we have the bisectors of the interior angles on the same side of the transversal. The bisectors, they intersect. You need to prove that they intersect at right angles. When two parallel lines are intersected by a transversal, then prove that the bisectors of the interior angles on the same side of the transversal, the bisectors of the interior angles on the same side of the transversal intersect each other at right angles. So you will have to just prove that this one is 90 degrees. Very simple, because what is the sum of these two angles, children? The sum of these two angles is equal to 180 degrees because they are co-interior angles. So this angle plus this angle, okay, is equal to 180 degrees. So if let me call this whole angle A, okay, and let me call this whole angle B. So A plus B is equal to 180 because co-interior angles are supplementary. Now let's divide both the sides by 2. That means you'll get A by 2 plus B by 2 is equal to 90. A by 2 plus B by 2 is 90. Now what is A by 2? Half of angle A. That means this angle. That means this angle. A by 2 meaning half of this angle A. So this one, because it's bisected. So this one, supposing I call this X and supposing I call this one Y, half of B as Y. Half of B is this one. Okay, I'll call it Y. So A by 2 is X, B by 2 is Y. X plus Y is equal to 90 degrees. And where is X and Y? This one is X, this one is X, and this one is Y. X plus Y is 90. Now this is a triangle. This one is a triangle. In a triangle, so this you have a triangle there. In the triangle, this is X, this is Y. The sum of these two angles is 90. So obviously this angle will be 90 because the angle sum property is 180. The sum of these two angles is 90. So the third angle has to be 90 degrees, which proves that the bisectors intersected right angles. That is what is the proof here, children. So I'll just read this for you. So see here, BEF. BEF is this full angle. DFE. DFE is this full angle is equal to 180, co-interior angles. Okay. Now divide both the sides by 2. So half of BEF, half of DFE is equal to half of 180. Every term is divided by 2. Every term is divided by 2. Now, what is half of BEF? BEF is this full angle. What is half of that? Angle 2. Angle 2. And what is half of angle DFE? DFE. Half of that is angle 1. Because DFE is this full angle. DFE is this full angle and it's bisected. So half of this angle is angle 1. So this one is angle 1 and this one is angle 2. So angle 1 plus 2 is equal to 90 because half of 180 is 90. Angle 1 plus 2 is equal to 90 degrees. See, this is angle 2 and this one is angle 1. So angle 1 plus 2 is equal to 90 degrees. Now take up that small triangle. Now take up this small triangle. In triangle GEF, angle 1 plus angle 2 plus FGE, this one is FGE, this one is FGE, is equal to 180, angle sum property. But we know that 1 plus 2 is 90. So instead of 1 plus 2, use 90. 1 plus 2 is 90. See here, 1 plus 2 is 90. 90 plus FGE is 180. So FGE is equal to 180 minus 90, which is 90. So we proved that the bisectors, they meet at right angles. Since it's time, children, I'm not giving you time to write. Take a screenshot. Those who have to write, please take a screenshot. Done, children?
Yes, ma'am.
All right. I think I just have 2 or 3 more. They're very simple. Let me just finish it. Another 5 minutes. I'll not give you time to write. You can take screenshots and complete it. Yeah, this one. All right. You can see the figure here, children. You can see the figure here. You will have to prove that angle X. Okay, you'll have to prove that this X is equal to alpha plus beta plus gamma. This one is alpha, this one is beta, this one is gamma. Alpha like this, beta like this, and gamma like this. This is how it is in print, okay? But when we write it like this. Alpha like this, beta like this, and gamma like this. Okay, they are letters of the Greek alphabet. Alpha like A, B, C, D. Letters of the English alphabet. Alpha, beta, and gamma are the letters of the Greek alphabet. Okay, now we will have to prove that X is equal to alpha plus beta plus gamma. Very simple. Simply produce AD. Produce AD. Produce AD to meet BC at E. Produce AD to meet BC at E. See, this is BC. So produce AD to meet BC at E. All right. Now this is an exterior angle. This is an exterior angle. Let me call this Y. Let me call this Y. This is an exterior angle. So this angle Y is equal to alpha plus beta. Exterior angle property. See, this is an exterior angle. This is the interior angle. Leave this. So Y is equal to alpha plus beta. Exterior angle property. See, this is a triangle like this. and this is the exterior angle. This exterior angle is equal to this angle plus this angle, alpha plus beta. So I've called that y. So y is equal to alpha plus beta exterior angle property. Now what is x? What is x? X again is another exterior angle. See, this is the triangle. For this triangle, this is the exterior angle. X is the exterior angle. X is the exterior angle. So x is equal to y plus gamma. Exterior angle x is equal to y plus gamma. X is equal to y plus gamma exterior angle property. But we know that y is alpha plus beta. So instead of y, you use alpha plus beta. See here, x is equal to y plus gamma. But what is y? Alpha plus beta. Y is alpha plus beta. So instead of y, you say alpha plus beta plus gamma. Plus gamma. So see here, let me write it for you again. Produce this. This one is E. This is Y. Okay. So Y is equal to alpha plus beta, exterior angle property. X is equal to Y plus gamma, exterior angle property. Now instead of Y, X is equal to, instead of Y, say alpha plus beta plus gamma, which is already there. So we proved that X is equal to alpha plus beta plus gamma. We proved that this angle X is equal to alpha plus beta plus gamma. Exterior angle property, we've seen this many times, children, in many different situations. Got it, children?
Yes, ma'am.
Yes, ma'am.
So here you'll have to prove that angle A plus angle B plus angle C plus angle D plus angle E plus angle F is equal to 360 degrees. Is equal to 360 degrees. So this, most of you might have already understood. There are two triangles here actually. There is one triangle AEC. There's one triangle AEC. So in this triangle AEC, angle A plus angle E plus angle C is 180. And there is another triangle DFB. In this triangle, angle F plus angle B plus angle D is equal to 180. Angle sum property. So in the two triangles, we just use the angle sum property and we add the two results. And then we add the two results. See here, in one triangle, oh, sorry, I made a mistake while writing, I think. Sorry, I made a mistake while writing here. In triangle AEC, children, this is. In triangle AEC, angle A plus angle E plus angle C. Okay, let me write it here. Ignore this slide. Let me write it here. Yeah. So in triangle ACE, angle A plus angle C plus angle E is equal to 180. Angle sum property. Angle sum property in a triangle, you can call this result 1. And then in triangle BDF, angle B plus angle D plus angle F is equal to 180 degrees. Angle sum property. You can call this result 2. This is result 1, this is result 2. Now 1 plus 2 gives 1 plus 2. Result 1 plus result 2 gives what? Angle A plus angle C plus angle E plus angle B plus angle D plus angle F is equal to 180 plus 180. Add the LHS, add the RHS. So angle A plus angle B, I'm just rearranging, plus C plus D plus angle E plus angle F is equal to 180 plus 180, which is 360 degrees. Hence proved. Yes or no, children? What happened? Are we all there?
Understood, ma'am.
Yeah. Children, please take a screenshot.
Taken, ma'am.
All right, please make sure you complete this. Don't forget. Yeah, with this we'll wind up the session for today. Yeah, this is the last one. Yes, children. So here in this one, the side BC of triangle ABC, the side BC of triangle ABC, the side BC of triangle ABC is produced to D. Yeah, you can see that it's produced to D here. Okay, BC is produced to D. The bisector of angle A, angle A is bisected. Angle A, angle A is this whole angle. It's bisected by AE. It's bisected by AE. That means these two angles are equal. This angle is equal to this angle. Not always. See, just because there is AE like this, it doesn't mean that these two angles are equal. Because it's given the bisector of angle A. Because it's given the bisector of angle A. The bisector of angle A meets BC at E. So see, this is the bisector of angle A. This one, it meets BC at E. The bisector of angle A meets BC at E. It's given it's the bisector. That is why these two angles are equal. Simply if there's a line segment that, like this, it doesn't mean that these two angles are equal. Only if the word bisector is given. So the bisector of angle A, so this angle is equal to this angle. Meets BC at E. We need to prove that angle ABC, this angle, plus ACD, plus this angle is equal to twice of AEC. Is equal to twice of AEC. All right, children. So, so see here, take a screenshot. Don't forget, take a screenshot, all of you. So since you have to get this result twice of angle AEC, what I do is I write angle AEC. I write an equation for angle AEC and then double that result. That's all. Write angle AEC, write a result for angle AEC and double that result. Now, but that, see, that result should, give you ABC, that is this angle, and ACD, this angle. That's important. So angle AEC is equal to, using the exterior angle property, angle AEC is equal to this angle plus this angle. See here? This is angle AEC. This is AEC. This is the exterior angle. This is the interior angle. Leave that. It's equal to this plus this. The exterior angle is equal to the sum of the two interior opposite angles. Yeah. Children, I'm sorry, I have just come back. 1 second. Yeah. All right, children. So this exterior angle is equal to the sum of the two interior opposite angles. So this is the interior angle. Leave this. These are the two interior opposite angles. So that's what I've written here. Angle AEC is equal to angle B plus this angle. What is this angle? It's half of angle A. This is angle A. And and since it's bisected, since angle A is bisected, this angle or this portion is half of angle A. This is half of angle A. This is the other half of angle A. So angle B plus a half of angle A. This angle is equal to this angle plus this angle. Angle B plus half of angle A. That's it. If you write this, you've got the result. So now double it. Multiply both the sides by 2. So twice of AEC is equal to multiply this one by 2. You can see it here. That's the next step. Now have twice AEC as it is because you need that twice AEC. Here you will have to do something and get ABC and ACD. ABC also we have already got. We already got ABC. Okay. So twice multiply both the sides by 2. So twice AEC is equal to twice of angle B plus half of angle A. So twice AEC is equal to multiply twice angle B multiply twice angle B and 2 into half of angle A. 2 into half of angle A. So 2 and 2 will get cancelled. So you have only half of angle A. So twice angle B plus angle A. Now what do you mean by twice of angle B? Angle B plus angle B. Twice of angle B means angle B plus angle B. Twice of angle B meaning angle B plus angle B. Okay, plus angle A. So twice of angle B is angle B plus angle B. Write this angle A as it is. All right. Now group angle A and B, children. See here, I'll tell you why. One minute. Yeah. Now see the required result. See the required result, children. You need angle B. ABC is this angle B, this one. And then you need angle ACD, this one. You need this one. So now what you do is twice of angle C we need. See till here, I think we should have understood till here. Twice of angle B means angle B plus angle B and plus angle A. Now what to do after this? Write this twice of angle AEC as it is. We need angle B. See here, angle B is there in the result. So have angle B. The remaining two you group because the remaining two should give you ACD. Here, listen carefully. The result has this one that we have here. The result has ABC. ABC means angle B. We have it here. We have it here. Now the result has another angle ACD that you have to introduce. That is not there with us now. That you have to introduce. Now, how will you introduce that? So that means this A plus B should somehow give you ACD. The remaining two things, A plus B should give you this ACD. I'm telling you again, we have twice AEC. We have one angle B, which is this one, ABC. Now we need to get angle ACD in order to get the final result. But what do we have? We have angle B and A. So that means this angle A and angle B put together, somehow we should get this angle ACD. That is why we are grouping. That is why we write this as it is and one angle B as it is. And we group the other A and B, the remaining A and B. See here, A and B. Okay, now look at the figure. What is angle A plus angle B? See, this is the triangle ABC. This is the triangle ABC. Okay, what is angle A plus angle B? It is equal to this angle. It's equal to this angle. Just take out this one. Just take out this line. Don't see this line. Don't see this line. Okay, then you have only the triangle. Then you only have the triangle ABC and this exterior angle ACD. Now this exterior angle ACD is equal to this angle B plus this angle A because this is the interior angle. Leave that. The two opposite angles. Interior opposite angles. Triangle ABC ACD, this is the exterior angle, and this angle is equal to, leave this angle, is equal to this angle plus this angle. So that means angle A plus angle B is equal to angle ACD, exterior angle property. Exterior angle property. So in triangle ABC, the side BC is produced to D. Okay, so by the exterior angle property, you have, write this twice AEC as it is. A plus B is equal to ACD. Why A plus B is ACD? Because exterior angle property, A and B together, angle A and angle B is equal to ACD. So A plus B is nothing but ACD. And this angle B can be written as ABC using 3 letters. B is nothing but angle ABC. Hence proved. Hence proved. Is it clear, children?
Yes, ma'am.
Yes, ma'am.
So it's all about writing this first thing. If you write this, then we have to double it because we have to get twice AEC. First, we write a result for AEC and then we double it. That's all. And then you should see to that you get this angle and this angle. This angle you already have. This angle you must get. All right, children, please, those who have not completed, please complete your classwork. With this, we come to the end of lines and angles. Saturday, we'll be starting the next chapter, congruent triangles. All right, children. So that's it for today's session. Thank you so much. You may leave the call.
Thank you, ma'am.
Thank you, ma'am.
Thank you, children. Thank you.